introduce myself. I'm Kelsey Hightower, engineer slash advocate slash a lot of things at CoreOS. And the talk that I want to give is on bootstrapping etcd. And bootstrapping etcd is actually pretty simple, but I do want to walk through the various modes of bootstrapping and also a really quick PSA about etcd. And the reason why this PSA is needed is because of one of the lessons learned that we learned in the 4.x line. So in the 4.x line, most people were building their clusters like this, where etcd was on all the machines, and standby mode meant that any of the machines could promote themselves to be active members of a 5 or to 9 size cluster. So this sounds really cool. You know, you're in EC2, spread across 3 availability zones, and you start out with nice balance where there's 3 nodes in each availability zone. Then you start rebooting things, and eventually all your nodes end up in 1 availability zone, and there's nothing you can do about it. And you lose that availability zone, that's it. You've lost, right? So it's really hard to try to build a cluster that way. And everyone did this by default. And this makes it really challenging to update etcd because we don't know where your active nodes are. You can't really protect those machines. etcd is a database at the end of the day, right? It stores data. And it's really hard to bootstrap a database at the exact same time that you're bootstrapping a cluster. So most people run into issues getting started with CoreOS because they're trying to bootstrap this etcd cluster and have these race conditions between apps that depend on etcd and actually being up and running. So one way that I recommend people test out etcd is if you really want to simulate the right way of doing it, in my opinion, etcd is a special snowflake. It really is. I mean, if etcd goes down, many of the tools that we build, Flannel, Locksmith, things like Kubernetes, it assumes etcd is going to be there, right? As long as you have etcd around, ideally you can bootstrap and bring everything else back in your cluster. But this needs to be almost the last thing that needs to go, just like the data for your application. And in production setups, ideally you want to run something like this, right? Because we use usually a tool called cloud config to set these things up. And doing a lot of etcd and CoreOS deployments, usually the only thing different between my cloud configs are the bootstrapping mechanisms for etcd. So if etcd is like the first thing and becomes like the beacon in your cluster, it's easy to make the other nodes just generic and point them at etcd. And etcd 2.0 ships with the proxy, where the proxy can be that thing that allows you to continue to connect to etcd on localhost, but the active members are well defined in the cluster, right? You're going to prevent a lot of issues. So when people come in IRC with bootstrapping issues or etcd issues, the first thing I do is point them to this diagram, point out the culprit, and it's usually this guy over here, and then I give them a word of advice, especially for production, right? This is great for demos because it's quick and easy, but in production, you really need to think about losing your entire etcd cluster. You know, you put your etcd group in an auto-scaling group, I give it about a few days and you will be on IRC looking for help. So really quick, so the goals here are bootstrapping etcd the right way, right? So a lot of people are really excited about this stuff, and a lot of people are actually running it in production even though we just released 2.0. So what I want to do is explore ways you can be a little bit more explicit about your intentions of running etcd in production and save yourself a lot of pain. So there's 3 primary modes of bootstrapping etcd today. One is the static mode, which if you know all your IPs ahead of time, this is probably ideal. You have the discovery mechanism, which also builds a static cluster for you, but also gives you the ability to do, deploy all your nodes at one time, like in the cloud. You know, you have a big, like you're using EC2, you have a cloud formation. You can spin up all your machines, and they'll sort things out. And then DNS, right? So a lot of people will allocate host names. I particularly like to use host names for things like etcd, and you can use DNS SRV records. So one thing to note about the bootstrap is it's only setting up the initial configuration. So if you reboot your cluster time after time, all the flags and parameters that you're using that talk about bootstrapping don't get applied again. So if you're using our discovery service that helps you set up a cluster that all comes up at one time, once it's done with that initial boot, that gets stored in the data directory, and you won't go through that process over and over again. And you can reconfigure your cluster later at runtime. So you see a lot of the flags say initial peer URLs or initial cluster state, right? Because that's exactly what it is, just your initial state. It can change later. So the first thing I want to talk about is the static bootstrap. This is a very explicit configuration. you know all the IPs of every member in the cluster. Has some drawbacks that you got to know all the IPs at once. This is very tough to do on, if you're bootstrapping inside of EC2 or something like that. And you end up with a lot of flags, which, very explicit. The IPs that you advertise to clients, because you could be using a public IP in the cloud that may not be bound to the server. So you need a way to advertise that. And then you have a list of your peers that you need to know about. And here, this is good if you have a bare metal setup and maybe all your nodes are actually provisioned already and they're given to you. Then you can actually be very explicit about that. So the way that works on the command line, each node in a static configuration gets a file that looks like this. You're very explicit about your name. Here I'm specifying the data directory and all the peers that make up that cluster. And also you can give yourself a unique cluster token. And these things are unique. These things help you from bootstrapping nodes that shouldn't be a part of the initial cluster. It will reject those. So to start this up, we can easily call static bootstrap. So the way it works is etcd comes up. So in static mode, it knows about its peers. And right now, it's looking for both of them. Right? It's having trouble even starting the cluster in the very beginning. It doesn't have enough nodes to form a quorum. So the nice thing is etcd just won't crash. Right? It's going to say, well, I know about all my nodes. They aren't there yet, and we haven't even formed the initial cluster. So we're obviously in static bootstrap mode. Right? So we move on to the second node, and he has a very similar config, different host name and IP, and we also give it the same static bootstrap. Now, two is enough to make a quorum of 3. Since we've given it the complete list, we know that we only need 2 to be there. And you can see that this node has published its cluster information, and actually the cluster is ready to start making progress. You can start adding data and removing data to it, even though that third node isn't online. Now, you'll notice there's messages and warnings on etcd because that third member is not available to get some of the replication events that keep the cluster healthy. So you'll see these until that third member pops online. We run over to the third member, and we do our static bootstrap, and he comes online, and he publishes his cluster data, and now we have a cluster that's good to go, and we see the errors stop, and the cluster is fully bootstrapped. So if you know your IPs ahead of time, you can just kind of do this, hard-coded IPs, cluster config, and be very explicit about your intentions of your cluster. Now, we also talked about proxy mode. So the static proxy mode uses a very similar config as the other nodes. Here we're explicit. We say that we want the proxy service to be on. There's no data directory because this guy will never store any data regarding the active cluster. This is much different than the standby mode. This guy only proxies requests to the active nodes. And here we're giving it the list of all the nodes. So this is ideally how we want you to run it in production. Every node or every client gets this config. And if we run it, we have our proxy up and running, and by default, we listen on the old etcd port, which is 4001, and then we get an official port assignment, which is 2379. This is why the proxy by default listens on both until people migrate over. And once you have your etcd cluster up and running, you can basically start interacting with it. And there's our list of members, right? So that's the static mode. Now, the next set of bootstrapping modes are really just a different way of providing a static configuration. You still need to know all the information, but maybe you don't have that information on hand. So you can use our discovery service, right? So the discovery service is the way to bootstrap an etcd cluster using the discovery protocol. Now, in our documentation, we detail what that looks like. You can use the hosted one on CoreOS, which is at discover.etcd.io. And a thing you'll also notice is we're being explicit again. We're saying what the size of the cluster is that we expect. So that way, if nodes boot up, slightly out of order, we know how many to wait on before we attempt to form the full cluster. So now we're being even explicit on the discovery side. And this is going to prevent tons of errors. It already has. And you can also do this on a self-hosted. So you have like one etcd up and running, you can run your own discovery service, right? It's just etcd and the way you make the initial call. So what we're going to do is just use the public etcd service. So, edible slides. All right, so what we're going to do is just get a token so we can bootstrap our cluster. So once we get this token, it can only be used once, right? So once you provision a cluster with it, you can't use it again. So embedding one of these inside of one of your cloud configs and trying to use it over and over again, it's going to fail, right? It's unique for that initial bootstrap. So what we're going to do is grab this token, And what we have to do is, number one, stop all the other nodes. And that's a little nice feature of them electing a new leader. So one is gone, and now we have a new leader. And one thing that I think it's safe to say is that the data directory really represents an etcd cluster, right? So if you want to do a new cluster, the thing you need to do is remove that data directory. If you want to preserve it, back up those data directories. So we have a little cleanup script that will do that for us. And we clean up across the board, and nothing to clean up on the proxy because it stores no data. So we'll quickly look at the discovery bootstrap. So here we need to tell the discovery service a little bit about ourselves. So we'll tell the discovery service the advertised URLs we want clients to connect to us on. And we also give it our peer URL so that our other peers know how to find us in the cluster. And that's it. And then we need to know the discovery token, which is missing from the end of my particular config here. So we need to add it. So what I'll do is I'll echo. Oh boy. I wish this was like Vim. I can just easily back this up. So we'll grab this. You have a trick? Someone has a shell trick. Everyone has a shell trick. Yeah, too late. So we'll do that. People get mad, like, you don't know the shell trick? I'm like, no, I don't know the shell trick. I'm sorry. Hopefully you'll let me finish the demo. OK, so now we have the discovery in place. And so basically that looks like you have your final flag in place. And hopefully this works. We run our discovery. And if etcd tries to be helpful, it's like, hey, I found one peer, which is myself, and now I'm waiting on the other two. So whoever set up that discovery token already initialized what size the cluster needs to be. So this thing won't start spamming your logs because booting up on the cloud could take, I don't know, 30 minutes sometimes if you're not paying attention. So as the other nodes come online, it continues to wait because we said 3.
Is that discovery token just a value, or is that actually querying a resource somewhere?
Well, it's talking to etcd. So behind that domain there's an etcd, and we do a little bit of magic to make sure you can't spam our etcd service. But basically, that's a key where your cluster information is stored. So ideally, we can take this key and go talk to etcd on the internet.
Well, wait, but which etcd is that coming from, given that it's...
That's our etcd in the cloud.
Oh, okay.
Yeah, like the magical place where unicorns live. That's where our data is stored. So that's the configuration. So we're basically using etcd to bootstrap etcd. And this is why you can use your own local etcd just to store this configuration. Just like we use in our other tools, we can store our data inside of etcd itself. And you notice that there's only 2 nodes that have shown up. And etcd is patiently waiting because we told it was going to be 3. And if you go and figure out why your cluster hasn't started, now you know why, because you're still waiting on a node. So if one of those nodes don't quite boot, you can fix that. So once all the nodes show up, everyone publishes their information. And why are things complaining? Stopped. Oh, we killed it. We killed it to give you your information. Go ahead.
Would that be because you already went to the web and got the information?
That shouldn't be a problem, ideally, because I think I currently didn't fully form the cluster. So let me clean up myself. Now I need a new token. Either that's a bug or I did something wrong. But ideally, what should happen is once all 3 show up, they all should just form the initial cluster. And I think maybe I killed the first node before we finished bootstrapping everything, and we didn't finalize the cluster. They all went down. So we'll clean up. And the last step is the DNS Bootstrap. So a lot of sysadmins like to give DNS host names to things, which is a good idea, especially if you're going to be dealing with IPs. So we did a little bit of work to make etcd smart enough to resolve DNS names. So even if you bootstrap it with DNS names, it'll go and resolve those names and commit those to its configuration. So this allows you to do maintenance a little bit easier, in my opinion. Now you can actually use DNS names, move things around, and add and remove things out of the cluster. And then as that node shows back up, even using this DNS name, it will resolve it when it's actually trying to send its messages. And to set this up, you're going to have an SRV record in place. So when etcd bootstraps off of DNS, it notes the number of nodes in the service to indicate the cluster size. And you just got to make sure that all your domain names are actually resolvable. And if they are, we'll go through the final process of seeing how that process works. Remember, we got to clean up our data directories. All right, so now we're all clean. And looking at the config for DNS bootstrapping, it's basically all the flags, but you have this discovery SRV domain, right? So this tells etcd where to go find the other members. And ideally, some of these URLs I won't need because they're already inside of our SRV record. But our advertised URLs need it because we have to tell the clients how to connect back to us. etcd does now have the ability to listen on multiple IPs. That was a pain point before. You bootstrap and you only have one IP, and a lot of people went through pain with that, especially with the proxy. So we do our DNS bootstrap. So this guy comes up, and you'll notice the first error. We attempt to try to find a secure version of the URL strings using HTTPS. And if it doesn't find that, it falls back to the non-secure URLs, HTTP, for our list of services. So if you have an entry for SSL, usually when you're specifying service records, you kind of put the name of the service. In this case, this is a secure version of etcd. And if it can't find that, it just falls back. So if you do have SSL that you want to bootstrap, this will work as well. So this is up looking for its members, can't find them, and it's pretty much the same process. All right, we come up, we found enough nodes to publish our cluster, and then we finalize it. And to me, where this feature is really useful is on the client side, right? So if you have a client, you can also just give things like fleet, or I don't think we built into fleet yet, but the idea is that you can give your clients a DNS SRV record domain to find all the DNS members in a etcd cluster. So if you look at our proxy service here, all we have to do is just say, hey, here's the discovery SRV record, go find the etcd nodes and do your thing. And ideally, that should come up. Do your lookup. All right, so we get the error because there's no SSL. We fall back, and then we try to be very helpful in our logs and print everything that we're finding, and now we're up and running here. And we should be able to get our list of members. So that's bootstrapping etcd. Those are the three primary methods you have for bootstrapping an etcd cluster. And remember the PSA here, you will lose your data probably and be on IRC. And this is ideal because etcd is a database, and you have to treat it like a special snowflake. Now, we make it highly available with all the RAF stuff that we've implemented, but you can't lose all of your nodes. And the best way to do that is try to find a way to isolate them somehow. Thank you. I'll take a few questions, and then we're going to take a break to have our final two talks, and I'll just go in order. Go ahead.
The SSL to standard HTTP fallback is what I was just saying.
Uh-huh.
Is that, can you tell it to not do that if you don't want to?
If you don't want to, we probably can add a flag like don't ever use SSL. But ideally, what you would do as the DNS administrator is just don't populate anything for HTTP, right? Just have nothing come back, and we won't have anything to fall back to. It just will fail the bootstrap process. Good question.
In that suggested setup where you have your etcd cluster that's separate from all of these other worker nodes,
Mm-hmm.
do you suggest not running anything but etcd on the nodes in the core?
I think that kind of depends on how much you need your data. If you don't really, no. So it's just like any other database, right? If you got to make a decision, let's say you have this database under a lot of load, the first thing you do is like no one runs anything else on the database. Like I have my shell server on there, like dude, take it off, right? That's the first thing that's going to happen. So just like any resource-intensive thing, if it's important to you, I think you shouldn't. So if you're running any virtualized setup, just carve out really small nodes. You don't have to have any big beefy servers for etcd in most cases. Just give it its own world to live in, and you won't be chasing why your other tools aren't working.
So my setup's a little bit interesting where we are running Chaos Monkey in production.
Mm-hmm.
And you said this doesn't work too well with auto-scaling groups. What would you suggest?
So if you think about it, you have this nice quorum going on with all three, and then you start auto-scaling.
Yeah, like min and max of set to 5.
Right, so then you're going to have to do some type of orchestration, like where are you going to get that data directory from? Right, so once you lose that data directory, so let's start off with 3 nodes. Everyone knows who each other is. They have their IDs in all the data directories. You blow away the node, you bring up a new node, gets a new ID. He starts chatting with the cluster, and the cluster's like, don't know who you are, reject. Now you're down to 2 nodes. and the auto-scaling keeps doing its thing. You're down to 1, and now you're dead. And then you're going to be on IRC talking to Rob, and that's it. So this is why I think, honestly, etcd is a database. If you wouldn't put Postgres in your auto-scaling group, you probably wouldn't do that and start killing Postgres. Don't do that to etcd, right? I think etcd does buy you time. So if you do have a mistake, like Amazon announces that they're going to do some work in AZ number or C, you have to worry. You don't have to really run with the pager because you have 2 other nodes that can handle that, right? As long as that node comes back up with this data directory, it's okay to have a node go down and up. That's really the key, built-in high availability. But you can't go blowing away nodes because that data directory and that unique ID are attached. If you lose that data directory, you can consider that node gone. And you have to go through that API that Brandon showed you, remove the node that's gone, and add a new node with that new ID and let it catch up into the cluster. Good question.
Isn't there a bit of danger in publishing the address of all of your etcd machines?
Only if people can get to them, right? Usually people have that security debate, right? Like, hey, I can get to your nodes. Like, those are all private to me. So yeah, you could.
So you put in private IP addresses?
Yeah, so I put private IPs in there. So you could try. You'd probably be hitting your own servers, dousing yourself, smiling until your computer shuts down. But you're right. I probably wouldn't publish my public IPs there. But ideally, a lot of people using like their internal DNS. So you can get, some people have like the split DNS going on, where you get a private IP if you make a query in a local network.
Is there a reason the nodes didn't seem to make any progress, even though they had a quorum when they're bootstrapping? Like, if you've got a 5-node, if you've told it it's a 5-node cluster and 3 nodes come up, why can't it start?
It did start. So you actually saw them publish there, like, hey, we're formed, and at that point we were ready to write and receive values, right? And this is why I was able to get that member list. So it will do it as long as it get quorum. Now on the bootstrapping side, it does try to chill out until all 3 show up, right? Because we don't know how long that 3rd node may come around because you're using the discovery service.
I guess I was thinking, my experience of AWS is sometimes their failure mode is you kick off a server and that one server decides it's going to take an hour to come up, or it never comes up. So I'd kind of like it if my etcd started, just gave up on that 3rd node and started being a 3-node cluster with 1 failed.
And this is just us trying to be a little bit more explicit. So it's probably easy for us to start continuing. But the thing is, most people, imagine if that happened, and then your cluster started going, and you thought you had 3, and you only have 2, and you lose that other one, now you're gone. So in that case, we're like, you're doing this whole dynamic thing. Let's just wait until your expectation is met before we start progressing. So this is something that we're doing on purpose. Maybe we can add like a, shoot myself in the foot flag. So if you want to do that, we'll let you.
Back to that architecture diagram where you had that
Okay.
cluster and then a bunch of workers. Is the expectation to run an etcd proxy on each of those worker nodes?
Exactly. This is exactly why we built a proxy. Amongst other things, right? Like people are asking for things like ACL support. If you want to scale a cluster, ideally what we want is all the local daemons running on one of these nodes to go through its local proxy, and that local proxy will have the ability to have all the addresses of the other nodes. And that's the way we want you to do it. So you can protect this kind of special island over here, but still give yourself that feel of etcd being on every server. Cool. All right, I think that's the end of questions. Let's take maybe a 5-7 minute break, and then we'll meet back here for our final 2 talks of the night. Thank you.